Hi guys, welcome back. If this is your first time here, please make sure to like, comment, and subscribe below. I'll be sure to respond to every comment that I receive. And who knows, in a future episode, your comment or question will be displayed. In this episode, part 2 of the 2-part episode on fact, I'll go over factoring questions that involve trinomials where the value of a is equal to 1 and polynomial expressions that need to be factored using grouping. So please stay tuned. Case 2. The equation says for us to factor, again, we're going to factor using our 3 steps plus 1, our 4 steps. The next problem reads k squared minus 13k plus 40 equaling 0, which is ideally what we want. So let's just do this following our steps, just so we make it systematic. First step, form. Yeah, we've got that. We see that our quadratic equation is equal to 0. Good. So we don't need step 1a. We can just go on to step 2. Step 2, factors. Now, we have to list all the factors that can possibly render us a solution here. In this case, it's a lot easier since our a value is equal to 1. So on that end, we just have 1 and 1. Don't really need to put anything on the left-hand side of our factors. We will just focus our attention on the positive 40. We need to list all the factors of positive 40, which we have here. So, of these factors, we need to look for the factor that in some combination can give us a middle value of negative 13, which leads us to step 3, combinations. The combination that we're going to be looking for, again, is the combination that leads us to a negative 13. Out of all the factors that are listed, we can just knock them all down except for 2. The numbers 5 and the numbers 8. When we add a 5 and an 8, we get 13. Now we want to get the right 13. In this case, the right 13 is negative 13. So, in order for us to get negative 13, that means both our numbers have to be listed as negatives. So we'll have negative 5, k minus 5, and negative 8, k minus 8. So our factors are k minus 5 and k minus 8. From there, we will go on to step 4. The zeros, man. It's all about the zeros. K minus 8 equaling 0 gives us a value of k equaling 8. K minus 5 equaling 0 gives us a value of k equaling 5. So our answers are 5 and 8. Wow, that was a lot easier. Let's try a slightly different problem that doesn't necessarily have to equal 0, but still requires factoring in order for it to solve. So the next problem is going to be this one. M cubed minus m squared plus 2m minus 2. Wow, that problem's a little different. We may have to amend our rules just a little bit in order to give us the flexibility to solve this problem. This problem looks like it's going to need another form of factoring known as grouping. Grouping simply states for us to separate, if we can, the polynomial expression, in this case not necessarily 100% quadratic, but the polynomial expression into 2 terms that are factorable. Then we're going to group the factorable terms together by like terms or something like that. So for this, we're just going to need to list our steps like we did before for the other form of factoring. We'll probably have 3 steps like before, and we'll add steps along the way if necessary. Fine, from time to time, I'm going to need to do that. So step 1, in this case, is not going to be like it was initially, where form, in this case, the form is there. Right now, the form that we're going to need to do, or the way we're going to have to do this, is to separate. We want to be able to separate this polynomial expression. So I'm going to split it right down the middle, as you can see on the side. Then we're going to go to another form of factoring known as greatest common factor. Yet another form that we're going to get to a little bit later. For factor, we have to find the greatest term that can go into both parts of the polynomial expression. After we split it down the middle, the greatest common term to both sides, or to each side separately, is different. On the left-hand side, the greatest common term would be m squared, because m squared can go into m to the 3rd, and it can go to m squared 1 time. M and 1 time respectively. On the right-hand side, it'll be 2, because 2 can go into both 2m and the number 2, m times and 1 time respectively. Now, if you notice, in this polynomial expression, we're going to have 2 terms that look alike. Step 3, make the factors that look alike into 1 element. What I mean by this is to merge the coefficients together, and also to merge the 2 factors that are in the parentheses together into 1 unit. Not merge by adding or subtracting, just merge into 1 unit. Again, you don't want to add or subtract. Don't do that. It's going to leave us with an expression of m squared minus 2 times m minus 1. That term is factored out. The roots for these aren't as important, at least not for now. Guys, let's pause now and come back next week and go into related topics to this, such as multiplying binomials, multiplying trinomials, the different methods of doing that, graphing, as well as some real-world applications of factoring, which I'm sure is very interesting to all you guys. Again, this is just a starter lesson. In the coming weeks, I'll make a lot more lessons on a lot more different topics that range from history to science, back to math again. Please make sure to like, subscribe, and comment below, and I'll be sure to answer your questions. I'm a knowledge guy, AKG for short. Signing off. I'll see you next week.